Hello and welcome back to this session of Bioinformatics Bootcamp. This is our final module, Module 4. We're going to be talking today about real-world data analysis, and we have a special treat because today we're going to be analyzing COVID data sets. They're very real-world data sets. They are scraped from various websites and trackers that follow the COVID data as it occurs. So it's actually kind of an interesting situation because we're going to be keeping up to date with the very latest trends in COVID. And so in some ways, the data we're going to be dealing with today is both very informative and very realistic, but also can be a little bit finicky. You'll run into some issues with things such as missing values. And so the questions we're going to be trying to answer with this data, they're going to synthesize all the things you've learned so far and really challenge you. So I hope this is a good experience. And I hope by going through this last module, you'll feel like you've got a good handle on what it takes to do some real world data analysis in your research. All right, so without further ado, let's jump in. So you're going to start out by going to our website. That's bigbioinformatics.org. That's again, bigbioinformatics.org, all one word, .org. Go to the R for IBMS page. Go ahead to where it says GitHub Workshop Repository right here. And you're going to go ahead and just download the code. So where it says download zip under code, go ahead and download that. Open that up, extract the files. It just takes a second. All right. Now I've got my files here. Go to module 4. Then go ahead and open up this .rproj right here. Just takes a second to load up on my computer. Okay. Oh, all right. And just one file today, and really not so much in this file. This is really a more bare bones exercise than usual. And the reason is because it's going to be a little bit more real world. So we're going to deal with that as it arises. You're going to have to download a package today called SARS-2-Pack. SARS-2-Pack is a package developed by Sean Davis, who is a leader in the bioinformatics field. And basically this is an aggregation of all of the data sources that are involved in tracking the epidemiological data associated with SARS-CoV-2 or COVID, as we're calling it. And so what you're going to be doing is you're going to go ahead and run this very first part here. This is going to download the package. Now, just so that I can make this a little bit more similar to what you're going to see, I'll actually uninstall this package because I actually already have it downloaded. So let me go ahead here and remove this. So we'll all be doing this together afresh. Now, some of you may run into errors or various things that go wrong as you try to do this. It's actually already asking me here something. Sure, I'll restart R. All right, so this should go forward without too much of a hitch. We'll find out here. Guess it didn't actually work. It's already struggling. All right, no. Say no this time, I guess. Okay, now it's going. So it's asking me here, these packages have recent versions available. It is recommended you update all of them. Would you like to update? Sure, I'll just say all. So put 1 here. All right. Now it's going forward and installing this package. All right, so I want everyone to try this. I would really like everyone to get to this point as quick as possible in the process. It may take you a long time to download some of these things. So that's why we just want to make sure that we start this now. You can say no to this prompt here. It's really fine. If you're having issues running this all as a block, you can run them line by line. So like line by line here. So one at a time. Just so you can see how that's working. All right. Anyone run into errors yet? I expect people will probably run into errors fairly quickly here. It's okay. We've got all the time in the world just to do this part, but I anticipate a lot of errors here. This is very realistic, very real world. The final test is whether or not you can load up this library SARS-2 pack. And of course, tidyverse. All right. So what's the status? Are people still downloading? Where's everyone at? Is everyone able to get it downloaded? Still downloading? Okay. Could not find function available data sets. That's because you haven't loaded the library. So you have to load the library first. Oh, you got it to work. Awesome. Nope. So when you load the library, then you should be able to run this line 17 here. So nothing has to show up after loading the library. If you've already got the library loaded, nothing will show up if you run this line again. So see, since I've already got it loaded, yeah. Nothing has to show up when you do library. That's actually not something that's really required. Okay, anyone? All right, so people probably still downloading. So for the people who reach this stage, we're going to actually get the data now. This is the part I'm a little bit apprehensive about, but they've got two functions: New York Times state data and Descartes mobility data. So these are the things that we're going to be messing with today. Okay. So once you've got it loaded up and the library command works, just go ahead and try to run these lines 21 and 22. Okay. So that's where I'm anticipating we will run into problems, most likely. These are large data sets and says doesn't exist. Okay. So, well, did you do line 7? Yeah, all 3 of these lines have to complete successfully in order for this to work. Okay. So, all right. If you've made it to line 11, if line 11 is working, okay. Can you put in the chat if line 11 is working for you? Just say like it works or done or something like that. Okay, works, done. All right. All right. So let's see here. So I think we're still missing Shahad. No, we're still missing Francine. Okay. So anyone else still stuck on this part? Matt, haven't heard from you. It says, yeah. So did you run these 3 lines? Lines 5, 6, and 7? Okay, are you sure? Because that would indicate, well, so run them individually. Yeah, run them individually. I'm guessing, yeah, I think I know what happened for you. So run them each individually and see if you can get that going. All right, so Francine, are you still downloading it, or what are you, what's going on your end? Okay, so is having issues with loading package. Oh yeah, but that's the problem. Yeah, like this is sort of what we talked about yesterday. Yeah, I'm pretty sure that's going to be the issue that you're running into, right? So can you put the text of the error message in your, this is a really great error, actually. It's like it's a very arcane error. But like, it's one that probably a lot of people will run into at some point. So probably worth mentioning it. Can you put the text of the error in the chat? Okay. So can you put the text of the error in the chat? Or share your screen or something? Francine, are you there?
Yes, I am. Sorry about that. So it was actually like loading and I couldn't rerun the lines, but I can share my screen.
That would be helpful.
Oh, 1 sec. Okay, can you see my screen?
Wow. Okay, this is what version of R? Okay. All right. So, yeah. Well, did you run lines 5, 6, and 7? Well, I guess now on your, yeah, did you run all those?
Yes, I did.
Are you sure? Because it doesn't, I mean, it looks like, well, maybe you restarted R or something, but just say no to that. Yeah, you're really fine. Okay, so that's working fine. You've got a very old version of RStudio and a very old version of R now. This is even older than the one you had last time.
Oh my gosh, I actually I did it the one I had and downloaded a new one. I thought this was the newest.
Yeah. Okay. So yeah. So you see the error you're getting there. So Francine is an interesting setup. The reason why you cannot do this is because you're actually in Dropbox, right? So you're running your whole PC from within Dropbox, but you're also running R from within Dropbox, and so that's why. Yeah. So you have to change your setup such that R is no longer inside of Dropbox.
Okay.
Yeah.
Okay. Cool.
Yeah, unfortunately, there's very little we can do about that at the moment, though. I would just say that will be a good task for the future, or get more space on Dropbox. One of the two, but yeah, probably don't really want to have R in Dropbox for future. Yeah. All right. I used to have R in OneDrive, so I know I've seen the same error with OneDrive. Yeah. All right. Was anyone able to, is everyone able to run line 17? Anyone having issues there except for Francine? Matt, is yours working now? What's happening on your end? Oh, okay. Letting it do all the updates. Okay. Yeah. Yep. Those can take a while for sure. Okay. So besides Matt and Francine, was everyone able to run line 17 successfully? Well, I guess line 11, we already know. Line 17. Yes, yes. Okay. Yes. Okay, great. All right. So what is line 17 doing? Well, line 17 is getting the available data sets that are within the package. So it's a package built on data sets that we use to understand COVID, right? So these are the data sets which are available in the package. We can see here we've got the CDC Social Vulnerability Index, our world in data, lots of stuff in here. lots of things that we could analyze. The whole purpose of this R package is just to make this data really accessible to our users so that we don't have to work too hard in order to provide insights to others regarding COVID and the societal impact of COVID, and also the efficacy of things such as social distancing, vaccines, and the relationships also with economic indicators, which I'm sure you saw in there. So there's a lot we could do with this data. It's a tremendous amount. What we're going to deal with today are going to be the New York Times state level data sets and the Descartes mobility data. So the New York Times state level data, if you do the question mark, New York Times state data to see the help page, basically you'll see the description here and it'll tell you that this is the number of cases, right? So the cumulative counts based on the best reporting up to the moment published. New York Times may revise the entries as new data comes in. But basically, this is, if you go on the New York Times website, this is basically the aggregation of their data sets that they've been publishing. All right. They also have county level data, but that's a massive data set. You really don't want to try to load that. Okay. So you can look through it more here, but basically, if you take a look at the data using Glimpse, so that's line 25 here, you can see the columns which are available. There's 5 of them, 57 or almost 58,000 rows. And you can see date, state, FIPS, which we see is the Federal Information Processing Standard. Not really sure what that means, but okay. Count, which is kind of what we care about. That's the number of cases, cumulative. And then subset, which is the deaths or confirmed, right? Okay. So that's the kind of data we have here now. We also have the Descartes mobility data. This is from Descartes Labs, and it's a measure of the amount of mobility of the average person at various times. So this also has date information. So if we glimpse it here, we can see it's got date, ISO 2, so that's an indication of what country you're looking at. Admin level, which is the, this is sort of for your, if anyone's familiar with GIS, right, this is for your global positioning. Okay, so these are sort of things that really are more in for the GIS folks. Don't really have to worry about that here. FIPS again, for GIS, right? Samples, number of samples observed in the specific region, M50, okay, and then you have here the M50 index. So the only thing we're really going to care about here is, for the most part, going to be the date, the admin 1, which is the state, and then the M50, which of course is going to be your median of the max distance mobility. So this is sort of the mobility within that region. Okay. All right. We also may want to use this M50 index since that appears to be standardized or normalized in some way. Or you could standardize and normalize things yourself. It's kind of up to you what you want to do. But these are the data we'll be working with today. So this is very real world data sets. So has everyone now run lines 21 and 22? Was everyone able to get that working, or at the very least, Shahad, Lauren, and Kate? Great. All right. So when we run these, we get the data sets, and then we've got a set of questions here that we want to use to address them. So the first question is, what state has the greatest total number of cases? Then what state has the greatest total mobility? Then question 3 is actually the most difficult of all, which is, what is the relationship between mobility and cases over time? And I've given you a bit of a hint here, but there's actually quite a bit more that will need to be done to address this. This is really the meat of the whole thing. We can also add additional questions if you end up taking less time than I kind of assume this will take. But for right now, I think this is a good set of questions to get us started. All right. If you were an epidemiological researcher, these might be the questions that you would have. So it's a good test for us. Okay. Before we do all that, though, and hopefully for for Francine and Matt, you'll all be able to catch up while we do this. We're going to go through the answers from last time because we had some challenge questions. And yeah, okay. But before we do that, any questions on this? Because this is kind of crucial. Any questions on this? Okay. Does anyone have a guess as to what line 4 is doing? What this if else statement is doing? Or sorry, just if. What this if statement is doing here? It's just getting us warmed up now. Does anyone have an idea what that's doing? Anyone take a guess? Exactly. Checking if it's already installed. Very good, Lauren. Yeah. So basically, if you run this function installed.packages, let's do that briefly here. It gives you a data frame where the rows are all of the packages that you have installed. Therefore, if SARS2pack is not installed, it will not be in the row names of installed.packages. That's what we check for here. So if SARS2pack is not in the row names of installed.packages, therefore it does not exist on our computer, and then we go through the process of installing it. However, this will do nothing if it is installed. So see, I have it installed, so this does nothing. If I suddenly uninstalled it, this would actually reinstall it. Okay. All right, let's jump back to the other one now. Matt, were you able to catch up with us? Okay. You have an old version of R? Yeah, you really, oh, okay. Yeah, I mean, this is like, that's why I was kind of like showing you all how to get R and RStudio in the beginning. You kind of need R4 for a lot of stuff. You really want, these days, you really want R4. Yeah. What version did you have? 3.6. Yep. Yeah, you want R4 from now on. Yeah. R4 or later. All right. Let's switch over back to module 3. So close this. Don't save. And we'll open up module 3 here. So you can do it just like this. Go to your downloads, wherever you downloaded the code, or wherever you have module 3. If you have your own version of it you want to use, that's totally fine. I'm just going to use this one since that way we'll all be starting afresh. All right, so okay, so the hands-on activity number 1 was to use empty cars. So let me run the library scripts at the beginning. And let's now do this. So the first question was filter empty cars for cars where SIL is 6 or more. So if you recall, empty cars has this column SIL, and it can have a few values, but we wanted to filter empty cars where SIL is 6 or more. Did anyone have an answer for how to do that? Very good. Exactly, Lauren. Very good. So what verb do we use? We use the filter verb. Filter where SIL is greater than or equal to 6. And now we've got our new data here. Nicely filtered. All right. The next part was to select the DISP and WT and MPG columns from empty cars. Does anyone have the answer for how we would do that? Okay, very good, Lauren, again, very good. All right, select DISP, WT, and MPG, right? We're using the select verb here, and these are the columns we want to select. So now you can see our data, but only with these 3 columns in it. All right, someone who's not Lauren. If anyone else has the answer to the next one, how would you group empty cars by the number of cylinders SIL? How would you do that? All right, very good. Yeah, that was a little bit of a softball. Group by SIL. Very good, Chad. Very good. Yes. Oh, wait, I misread yours, Jihad. It's Francine has the correct one. Well, you're both actually sort of wrong in different ways. Close though. Everyone was close on this. Francine, the only thing you were missing is that this is not capitalized, but otherwise, exactly. All right. So how would we add up the number of cars in each cylinder group? Can someone give me the code I would need to do that? Okay, Lauren is now, you're not banned anymore. You can come back and give an answer now if you want to. Everyone's got a chance to do this. All right. Okay. All right. So Lauren, that is correct. Very good. All right. You're now banned again from giving answers. Group by SIL. And then you can do summarize. Exactly. Summarize the UK or American way. You can do it either way. Actually works for both. They're very inclusive. N SIL group equals N. Someone who's not Lauren, can you tell me another way to get this? What if I didn't want to use summarize here? Does anyone know another way to do this? This is actually a little bit of a challenge question now, since I actually don't think I showed you this yesterday, but does anyone happen to know what the other way to do line 85 here is? Okay, so I'll show you. There's another verb that actually you can use as a shorthand for what we had there on line 85 to summarize N. Instead, you could just simply use tally. Has the exact same effect, except that the column will be called N, so you don't get this nice named column here. So that's the only real downside to it. But yes, you can use tally. Very useful. Okay. Either way is good. All right. Can anyone tell me how to calculate the median weight, WT, within each cylinder group? Okay, very good. Very good, Lauren. Okay. All right, so exactly. So you would do group by SIL. So we're grouping it by cylinder. And then we're going to find the median weight, which is WT. So summarize again. And you can even make a new column if you want. So med WT here. And then you can just say median weights. And you can see now that worked just fine. So that gave us the median of the WT column, but within each group. So this is our roll up. Basically, this would be a fairly consistent sort of data science workflow for a lot of people, because you start with some groupings and then you summarize them down into based on some statistic that you are interested in. All right. Someone who's not Lauren, can you tell me the answer to the next one? Create a new column which contains the ratio of horsepower to miles per gallon, MPG. And only keep the cars with WT greater than 3. So there were two parts to this. Can anyone tell me either how you would do either part, or if someone has the answer to both, you can tell me that as well, except for Lauren, who's answered too many. Okay. So could anyone, okay. Okay. All right. This is very close. What you put there, Matt, is very, very close. Okay, so let's start with the first part here. You've got the first part absolutely right. Well, sorry, very close on the first part. So you said summarize. And while I believe that actually would technically work, it's not really the way that we would typically want to do this. We would usually want to use here a mutate statement. So mutates, recall, summarize is where you're going to typically collapse down a group and summarize it. But mutate is where you're simply adding a new column, right? So in this case, we want to add a new column and we want its value to be the ratio of horsepower to miles per gallon. And very close with the summarize though. That might actually work. I really don't know. All right, mutate, and we're going to add a new column, which we're going to call MPG HP ratio, just like Matt did. And it's going to be HP over MPG. So that's the first part. So let's just run this part by itself. We can see that this, in fact, does work. And we get this nice ratio column here, and it is the ratio of MP or HP to MPG. Now, the next part was the filter part. And I said filter, or sorry, I said only keep the cars with WT greater than 3. Now, I think, Matt, you might have made just a slight error here because in your filter, you actually don't have WT. But yeah, but otherwise completely correct. WT greater than 3. All right. And that's our answer here. Okay, and then finally, group the cars by gear and then find the average HP to WT ratio. Lauren's also not allowed to answer this one. So someone else, Shahad, Matt, Francine, Kate, do any of you have an idea on this one here? Also good, you got the COVID packages, good. All right, excellent. Does anyone have the answer to this? This one was a little bit tricky. This one was actually quite tricky. Okay, so you've got one part of it, which is the group by gear. Okay, so let's start with that part then. Group by gear. Okay, good. So Shahad got that part. All right, what would be next? Okay, mean, but how would you write it? How would you write it from here? So it is mean. Mean is the function you would use to summarize, but what would be the actual line of code you would use following this to get that? Okay. Okay. There you go. Very good, Francine. That is very close. That is very, very close. Let's just show what that will produce first. Okay. So group by gear, and then we do a mutate. This is what Francine has shown here. AVG equals mean HP over WT. Now, this is technically correct. So let's show what this produces here. All right, so we can see here we have managed to achieve the average horsepower to weight ratio within each group. Right, so we have actually done that, but we've been left with all these duplicates. Why is that? Can anyone tell me why we have been left with all these duplicates here and how we could potentially use a different verb to do this? Maybe something other than mutate. So again, remember, mutate adds a column, but it doesn't change the number of rows at all. It just adds a new column. Summarize. Okay, good, good. Very good, Lauren. Exactly. Summarize. Now, the difference again between a mutate and a summarize. A mutate is just going to add a new column. You're not going to remove any columns. You're not going to remove any rows. A summarize assumes you're kind of at the end of your analysis and you're ready to collapse your data down, right? So the summarize is going to collapse everything down to the groups you've specified, and it's going to have the columns you've specified in your summarize statement. So it's just going to be your groups and whatever column you gave to the summarize statement. And so let's say we're totally ready to be like at the end of our analysis, we've reached our final goals here, and we're ready to just find out what's the average horsepower to weight ratio. We would use that summarize. But if we still wanted to keep going, but we still wanted to have this information as we continue to go along, well, then we would use that mutate, because the mutate is not going to reduce the number of rows. It's not going to collapse everything down to groups. It's not going to get rid of any columns. So yeah, that's the main difference. It can be kind of confusing at first when to use one versus the other. I'll just tell you now, you're a lot more likely to use mutate than you are to use summarize. Mutate is a much more common verb when you're analyzing data, especially real world data. But summarize is very useful once you reach the very end of your analysis. All right. Any questions on what we've done here? Any questions on this challenge? Are people starting to feel fairly comfortable with using these verbs in tidyverse? Okay. Okay. Good. Good. It takes time, like anything. There's a huge learning curve when it comes to learning R and learning tidyverse, but you'll find it truly is worth it. Tidyverse makes you very, very fast, very efficient. Ultimately, it's a much more user-friendly way to use R than base R is. So I find it to be the superior way, at least for me, to use R, especially for data science applications. All right, last part here was to do a little bit of plotting. So for the very first part here, we were going to use the iris data set. Sorry, for the whole thing, we're going to use the iris data set. Now, the iris data set is a data set that contains observations about 3 species of irises, Setosa, versicolor, and virginica, and you've got the sepal length, sepal width, petal length, and petal width. You will see this data set many times throughout your data science experiences because this is a very common data set for people to use for testing various machine learning and data science approaches. So it's fitting that we use it here. First order of business was to group iris by species. Can anyone tell me how to do that? Anyone have the answer for that? Yep, very good, Francine. Group by species. Very good. Yeah, very good, Kate. Very good. Group by species. See, this is getting easier to pick up because again, tidyverse is like you do it how you would say it. I want to take my data, I want to group it by species. Then I want to take my data, I want to find the average sepal length to petal width ratio per species. So how would I do this? Getting back into sort of those complicated statements here. So how would I do this one? Okay. Very good, Lauren. Yes, that is a very good answer. All right, so this is what Lauren has. So you first did the group by species. Okay, very good. Okay, I'm going to talk in a second about why Francine's answer is also very good. And perhaps in some ways, it's more similar to what I would personally do. But all right, this is what you have in your mutate statement. So it's sepal length divided by petal length. And then you have this big long column name here. And then you've got your summarize. So sorry, I'm just going to copy and paste for now because I'm losing a lot of time typing this out. All right. So then you've got your summarize. So how is this working? Well, we see it works just fine. And the way it's working is that you first create a new column, sepal length to petal length ratio, right? So if we just look at this part without running the summarize, we can see you've created your new column, sepal length to petal length ratio here. And then you've gotten the average of that in your summarize. So very good. Now, what was Francine's answer? Let's take a look at that. So you had the group by species was the same. So let's put that. And then you did this, which I can tell you're not actually running this in RStudio because you would see that that's actually not the names of those columns, but your intuition for how this would work is correct. So let's put the actual names of the columns here. Summarize, and this is also lowercase. There we go. Summarize, mean, okay. So that also works. And not only does it work, but it is a little bit simpler and less wordy. Exactly, it's a little bit less verbose. Now, the way that we write code is, yes, it is for ourselves. It is for us based off of how we understand the analysis pipeline, but it should also be as much as possible for others. And so while I do think that, Lauren, your code is very good, I would personally caution you to avoid, as you start to get better and better, to try to avoid long column names and verbosity, because while that can be helpful while you're learning, it may make it difficult for someone else to review your code later. And as someone who now does a lot of code review as part of the collaborative projects I work on, I am very sensitive to that issue. But either way, the code works, and that's the important part. See, it works just fine. You get the same answer with both. All right. Now comes the fun part. Pipe all of that into ggplot2. Set x-axis to species and y to the ratio column. All right. Anyone have the code for that? Okay, that's very close, Matt. That is very, very close. So you actually don't need to put that dot there. But yeah, you could. That actually would work. So it's a little bit of an interesting thing. For now, I'm actually going to use Lauren's answer, even though I just like kind of bashed it a little bit. I'm going to use your answer because the name you gave the column was a lot smaller than the name that would show up for Francine's answer. So pipe that into ggplot. So are you able to run this in R? I mean, I know you have an older version of R, but you should be able to run tidyverse still. Tidyverse should still work. Okay. Yeah, so this is what Matt had. AES, X is species, which I think is supposed to be capitalized here. Y is the ratio column, which is AVG ratio. So you can see that works just fine. Does anyone know what this dot represents? Someone happen to know what that means? It's actually a specific thing. It's kind of arcane, I guess, until you get to a more advanced tidyverse, but might as well mention it now. So the dot is just a representation of the data that was coming from the pipe ahead of it, so or behind it. So the data is piped through all the way through. This dot basically says, I want to take the data coming from the pipe, coming from the preceding steps, and I want to take that data and put it right here. Now, that will happen by default if you just don't include it. See, that still works just fine, but this is a more direct way. It's actually, you can use tidyverse is extremely powerful. Most people don't realize exactly how powerful it is. You don't actually have to only use tidyverse functions in the tidyverse style. You can actually add other things as well. So, all right, I'll get into it later because I could go down a tangent here. But if we have time at the end, I'll show you some pretty crazy stuff you can do with this. Okay. So let me get rid of this for right now. So yeah, very good. Okay. Does anyone know how to add the bar plot geometry to what we have up here? So assuming we take everything that's up here and we paste it in here, how will we add the bar plot geometry to this? There's actually a few correct answers to this. So let's take the first answer that Francine gave. That is not the bar plot geometry. It's just a different geometry, but these geometries are completely interchangeable. So you can see here, geom point. Well, it makes points, right? Geom call, which is what Lauren suggested here. Let's take a look. Now we've got our columns. Very good. Very good. You could have also done geom bar, except that will produce an error. And that's because the bar geometry has a special requirement that you set the stat, because bar plots can actually represent lots of different things. Geom call is a particular statistic, but bar plots in general can have lots of different statistics associated with them. So stat identity is how we just make it a normal run-of-the-mill bar plot. But geom call is basically identical to what we just did here, and it's simpler, so that's why we do geom call. All right. Usually, when you're making bar plots, you'll want to use geom call. Next, set the y-axis label to average of sepal to petal length, cm. Can anyone tell me how to do that? And I'm just going to copy and paste what we have so far. So how would you add to this in order to do that? I'm happy to explain what identity means. Yeah, well, I'll explain that. And if anyone has an answer to this next one, put it in the chat while I explain this. So basically, oh, sorry, geom bar stat identity. So one way to address this question is just to look at the manual page for geom bar. So you can see here where stat is. So it says stat count. That's what it is by default. So by default, it would be set to count. So what is geom stat? Okay. All right. Stat. Sorry, I have to like search inside of here for this. All right. This is like not particularly informative. They don't really explain to you very well. This is bizarre to me. Well, all right. So I guess they don't really want to tell us what it means here. That's fine. Basically, stat count is the function that is controlled by that stat argument here. So let's take a look at stat count. Yeah. All right, this is a little bit of a dead end. I'll just tell you now, I know this because I've run into this question before. And okay, sorry. Let me just show you how I found the answer originally. I'm like trying to show you the proper way. Let me show you how I actually did it, which back when I first was learning R and ran into this error for the first time was maybe not the proper way, but that's fine. So I just took the error, copied the whole thing, pasted it right into Google. First answer Lots of upvotes. Basically, very first answer to this says you need to include stat equals identity, which is basically telling ggplot2 you will provide the y values for the bar plot rather than counting the aggregated number of rows for each x value, which is the default stat count. So basically, if you had, for example, species, yeah, so like let's not supply, let's actually like override this for a second here and just do it this way. You can basically see here that the count is going to be the relative number of x's. So relative numbers of Setosa, versicolor, and virginica, right? So in our case, I mean, we have, I guess, the same number of each then. So not particularly informative, is it? But basically, it's just counting up the relative contribution of each. So yeah, it's basically a histogram or a frequency chart. Yeah. At least I think that's what it's doing. To be honest, I basically never do this, so I don't know for sure. All right, let's go back to the way things made sense. All right, there we go. When you say identity, you're basically saying the height of these bars is the y, right? So you're saying the height of each bar is the y. Whereas without it, with stat count, the height of the bars is going to be calculated by geom bar. Yeah. This is why we just use geom call, because it's a little bit more explicit in what we want. All right. Did anyone figure out how to set the y-axis label to average of sepal to petal length, cm? Does anyone remember what command you use? Okay, all right, there you go. Very good. Very good, Lauren. It's plus ylab average. I'm just going to copy and paste this. I'm just going to show you here. All right. Plus ylab average of sepal to petal length, cm. And there you go. That's how you control the y label. All right, so let's take everything we've got so far, paste it in here. Now, how could we modify this such that the plot was colored by species? Does anyone know how we would modify this such that the plot would be colored by species? Yep. Put fill in the, yep, exactly. So in AES, we could just supply here fill equals species. And there you go. Not too bad. Finally, set the title to iris flower analysis. Can anyone tell me how we would take everything we've got so far and do that? Not Lauren. Someone who's not Lauren. Does anyone recall how you set the title? Okay, I'm going to give you guys 10 more seconds, and then I'm going to let Lauren answer because I'm suspecting. Okay, very good, Francine. Exactly. GG title, iris flower analysis. Does anyone know the other way we could have gotten this? Lauren can answer now if you know. There's actually another way. Exactly. So the other way would have been to do, so let me comment this out here. The other way would have been to do labs title iris flower. Same thing here. Now GG title, I just want to make sure this is actually correct. Okay, that actually is This is basically just the shorthand for doing what we just did here. So in some ways, GG title may be a better way. It's not actually one that I usually use. I usually do it the old-fashioned way, like this, but either way works just fine. Okay, you've got a ggplot2 cheat sheet there. Very nice. Yeah, this is a good one. So yeah, all right. This is a good time to talk about RStudio. So if you go to RStudio cheat sheets, so RStudio are the people who develop the tidyverse. They develop RStudio, obviously. They develop a lot of stuff in the universe of our data science. And they have these RStudio cheat sheets that are excellent. You can do pretty much everything here: tidy evaluation, deep learning, dates and times, strings, apply, data import, really everything. The data visualization one you just linked is actually just an older version of this one that they have right here. Really quite a lot here. It's like crazy what they have. Yeah, truly insane what they have here. I think they even have dplyr somewhere in here. All right. But data transformation here. So I'm going to link this in the chat. So this would be a great way to keep up to date. To be honest with you, when I was first learning tidyverse, what I would do is I would take this data transformation cheat sheet. I would just print it out and have it on my desk in front of me while I was coding, because like it was really helpful just to refer back to it. Because like, for example, check it out here. This is like your group by and summarize. It's basically showing you visually what that means. So you've got your groups, you group them, and then you summarize them. So like it's a nice visual representation of what these verbs are doing. Very useful when you're first starting. The one that you'll really have a hard time wrapping your head around is going to be things like left join, right join, full join, right? So like how you join data sets together. That's going to be a really tough one when you first start out. But once you master it, it'll feel very easy. This is a really good way, just before you feel like you've got a handle for it, this is a really good way to basically continue moving forward. All right. Again, RStudio, very, very awesome company. They develop all of this, and sure, they profit from it, but the resources that they provide for free are truly transformative for the field. So check this out when you get a chance. And I guess I'll include this in the on the website as well for today. So for people who are not able to make it to today's session, I'll actually have a link to this on the website for the course. All right, so we've now gone through all of that. Any questions on this? Any questions on the tidyverse? Any questions on data wrangling in tidyverse before we jump into the real work today, which I think we'll have just enough time to go through problems 1 and 2 and maybe 3. We'll see. We'll see if we get to 3. No questions? Well, if you have questions at any point, feel free to put them in the chat. Let's now switch over to the module 4. Switch back over, I should say. Downloads, go back to where my downloads are. Module 4. Just click through to the R project there. All right. So we're back in, which means we need to reload that library. So this time when you run this, you should see nothing happen. But when you run the library, you should see it load up. You should see tidyverse load up. You should be able to see the available data sets. You should be able to load up the data. Really hoping that this is working for everyone. I'm like a little bit worried it won't, but all right. And you should be able to glimpse both data sets just fine. I'll ask one more time. Is anyone, except I think for maybe Francine, is anyone not at this point? Has anyone encountered any errors? I think for future workshops, we'll probably do things on RStudio server or RStudio cloud just to avoid sort of the issues of people's personal computers. Okay, all right, very good. So then let's move forward here. First of all, a little bit about where this all comes from. It all comes from the SARS-2 pack. The available data sets we already talked about are here. You've both gotten both of these data sets. So what is each data set? Well, if we look at the help page for the New York Times one, we can see what it is. If we look at the help page for the Descartes mobility data one, we can see what it is. Okay. First question, which state has the greatest total number of cases? So go ahead. And question two, which state has the greatest total mobility? So let's go ahead and start with question one. So I'm going to go ahead and give about 10 minutes. Well, is that too long? I don't know. I'll give 10 minutes, but when you're done, just say done. Don't put your answer in the chat this time. Just say done if you're done in the chat. And then that'll give me a sense of how long this is going to take people. So go ahead, start with question one and see how far you can get. We'll meet back up again in 10 minutes. Again, when you're done, put done in the okay. So sorry. Simon asks, counts in the New York Times are cumulative. Right. Okay. The M50 in DMD2, or we need to sum that one. Yeah. Okay. So it's so basically, if you've got any questions about your data, make sure. Yeah, I just realized that now. Make sure to just take a look here, read through the column descriptions if you have any questions about what's in each column. Again, the counts are cumulative. All right, let's go ahead and try that. So you got 10 minutes to answer those. To answer that first one, question one. Sorry, go ahead and answer that now. Okay, so we're gonna give it a few more minutes, but just really quick, anyone running into any issues, anything, if anyone's got any errors or anything that they're running into, feel free to like message me or Simon directly, and we can both help you offline. But that way you won't have to accidentally post like an answer or something like that. All right, so we got a couple duns here. I'm thinking probably go ahead and give another 3 minutes on this one. Give it a little bit extra time on this one. Okay, so hopefully that wasn't too bad. So it looks like we got a couple answers for it. All right, so would anyone who was able to get an answer for that like to share their answer? All right. Okay, very good. So does anyone have a different answer? I was actually a pretty advanced one you did there. We didn't actually um you couldn't get it to give the state name too. Okay. So let's yes, yeah. Yep. Okay. So there were a few solutions to this. Okay. There are a few possible solutions to this. A lot of them were more direct, some of them were less direct. Simon put his solution. Why did you send it to me as a direct message?
Me too. Sorry, I'll put it in public.
Yeah. So quick question. What was the number? What was the state and what was the number? Can anyone tell me what the state was and what the number was? All right, good. Yep, exactly. Did anyone possibly get any different answers at first? I feel like I kind of hinted at the issue that people would run into from the beginning, but okay. So so Matt, you said you got a slightly different answer. Well, let's first talk about the real answer and let's talk about something that you might have gotten that would have been slightly different. Right, exactly. So if you use sum instead of max, right? Okay, so what did I ask for here? I asked for the total number of cases. And when we say the word total, we're often primed to think the word sum, right? But we're dealing with cumulative data. So let's just take a look at this first part. So pretty much everyone had the same thing here for the first part, which was to take, to take the New York Times data, to group it by state. Now, something that Matt and Lauren did not think to do, but which you didn't actually have to do it, as it turned out, but which if you would ask a different question, you would have had to do. That was to actually filter such that the subset is confirmed, right? Because remember, subset could be deaths or it could be confirmed. We actually have both types of data in here. So you didn't actually have to do this because the specific question we asked was not related to something that would have been compromised by having the other type in here. But just know that when you're dealing with data in the future, you'll want to make sure you're keeping in mind of what kinds of data you have, right? So we have both deaths and confirmed in here. It just happened to be that confirmed was the larger number. All right, then we went on to do the group by. Oh, sorry, we did the group by already. Sorry, to do the summarize. So summarize max count. So I'm doing it Lauren's way. Here is max of count. So we're getting the max here. So if we just do this, we get the each state with the count. Now, if you had done the sum instead, you would have seen something that looks like this, where California has like almost a billion cases or something. Yeah, something crazy like that. So that's how you knew that it was actually max instead. All right, so what was actually the max value? So now everyone did this one slightly differently. Now, if you were just using things you had learned up until this point, you could have done the base R way, which was to just assign this to a variable. So let's call this dat for data or df for data frame or whatever you want to call it. And then we could have gone df state df. And then we could have found the which equal to max, right? So like this would have been a totally valid way in base R. So if you find the max count, and then you find which is equal, or you don't even have to do that. You actually don't even need the which here. You're just saying where this count is equal to the maximum. That would have given you California. But there was actually a tidyverse solution, which Matt pointed out. I'm assuming, Matt, you might have Googled that. Very good. Arrange in descending order, max count. You certainly did. Yeah. Yep, because I know that when you Google how to arrange a tibble in tidyverse, that's like the very first thing that comes up. Or how to arrange it in descending order, that's like the very first thing that comes up. However, there was even a better tidyverse solution, which was slice max. So slice max, max count. And that will give you the very top observation in your tibble based on a particular column. Okay, so you did learn arrange in tidyverse. All right, very good. Very good. But yeah, there were lots of different solutions, and just like so many things in R, there are so many ways to skin a cat. If you had just the things that we had talked about during this particular workshop, it would have been this. If you wanted to use arrange, it would have been that way, or slice max, it would have been this way. Unfortunately, the one way that wouldn't have worked here was the way that Lauren, you tried to do it, because the summarize that you used, while it does give you the value that is the max, so I'm going to show you Lauren's way here. While this would give you the value of that maximum, it will not tell you which observation it belongs to, right? So it wouldn't have said California here. Close though. Very close. All right. All right, so all right, I think we've got time for just one more question, which was question 2 here, and then we'll wrap up. We'll probably end a couple minutes late, probably end right around 7. So I was hoping to get out by 6:50, but we might end up at 7 here. So go ahead and take a shot at, well, actually, sorry, first, before we do that, does anybody have any questions on what we just did there? Anyone have any questions on how we did that?
Can you explain how the slice?
Yeah, absolutely.
Work?
So slice is just going to take a tibble, and you can basically see here what it does, right? So it lets you, sorry here, I was taking a look through. So basically for slice max, well, that one's actually pretty straightforward. So you basically just give it the order by. So order by is what we're supplying here as max count. So we're basically saying order the data by max count and then take the maximum of that. Right, so it's very similar to what Matt did actually, where you arrange the data in descending order and then take the first observation. That's basically what this is doing in just one step. You can also supply an N, and that will give you however many top observations you want. So slice max can return an arbitrary number of observations that are the top in order. So if I put 10 here, I can see the top 10. It's a very useful pattern to use when you're coding in tidyverse R. Okay. All right, so go ahead on now to question 2, and let's see how far we can get on that in 10 minutes. And when you're done, just say done in the chat. That's a good question, Matt. So I'll get to that in a second. Yeah. So yeah, so look at the hint, because basically the hint is kind of the way you would deal with it, right? Because you can't put two different tables into ggplot. So that's for question 3. Yeah. Which we haven't gone on to yet, but you can't put two different tables into ggplot. You'll need to combine the data. And so basically, that's how you would combine them. Or that's one way you could combine them. Yeah. Okay, so how's everyone doing with this? Are people getting this? Is anyone else done? So it looks like we got Matt. Anyone else done? just for question 2? So what is okay, so this was kind of a good question, right? So maybe Matt, do you want to put your answer? So yeah, so if you look at the columns of okay, I'm just going to share my screen. All right. Hold on a second. Let me delete my answer first before I show this. All right. So how would you know what the mobility is? All right. So if you look at the help page, so everyone was able to find the help page, right? So it's just the page that you get to from putting question mark and the name of the function, right? So the mobility data is this column, M50. You could also use the M50 index. These would both be valid, but you would have to make an argument in some cases as to why you would use one or the other. But either way, you could do it. You actually get the same answer no matter which one you choose. But yeah, all right. So given that, is anyone else done? Yeah, so it would be the sum. Yeah. All right. Well, for the sake of time, let's go ahead through the answers here. So even if you've only got a partial answer, feel free to put it in the chat. Maybe Matt, you can put your answer in the chat. All right. All right, good, good. All right. Okay, good. That's the way I did it as well. Right. So which state has the greatest total mobility? So two very similar approaches here from Matt and Lauren. I'm going to take Lauren's because it's the one that I also did when I was solving this. So you take DMD, you group it by admin 1, which if you recall, that is the state. So hold a second. If you do your glimpse on DMD, you'll see that admin 1 is a state. So Alabama, Alabama, so on and so forth, all the way out. So that's admin 1. Summarize with the American English way. Total mobility is equal to the sum M50. So that would be one way to do it, yes. And then arrange. So sorry, I'm doing it the most efficient way. Slice max total. All right, and we can see here the winner is Texas. Texas is probably the winner for several reasons. Sure, many of you have realized since coming here that Texas is a place where lots of people drive lots of the time. So it would be hard to, in general, in non-COVID times, beat Texas mobility, but we also do not necessarily shut down for pandemics. So mobility, probably Texas is the top. All right. Yes. Yeah. Don't want to get political. I just feel like, you know, San Antonio's mayor and Texas's governor are going to have it out, and we'll just see how it goes. We'll see how that all turns out the next week. All right. So the last question, which I don't think we've got time to do this independently, though, is what is the relationship between mobility and cases over time? For this question, you will need to perform a bind rows. Okay. So in fact, though, to be honest, you didn't have to do that if you wanted to find a different way. So just first of all, did anyone have an answer to this, or anyone started working on it? Anyone want to show what they've done so far? This was a very difficult problem. Like the ramp, there was a ramp of difficulty from 1 to 2 to 3 that was pretty steep. But yeah, I was going to plan to give you guys a long time on this one. All right, so no one has an answer for this. I'll go ahead and show you. So this is a very like research like question. What is the relationship between mobility and cases over time? Right. So there were a few ways to address this. One was to plot it. I'll just show you, even before you bother to do that, how you could have addressed this. So the way you could have done it was to take New York Times. Well, so this is sort of what we did here, right? Take the New York Times one, and you could have taken the there we go. So could have taken the DMD one, right? So let's say that we want to just do this, right? So this is fairly straightforward. The reason we do this is because these are very large data sets, and we don't necessarily want to do a full join on them in a traditional pipe, because that will be a pretty intense operation. So we're going to join them on date now, and we can use the inner join to do that. So the inner join, again, from that cheat sheet that we saw before, this is one way to address this question. You don't have to do it this way. This was just the way I would personally choose to do it myself. So in an inner join, you have an X, and that would be NYT, not MYT. Your X would be NYT mod. Y would be DMD mod. By would be date. So when we do an inner join, we're basically saying I want to take both of these data sets, and I want to combine them into one, and I want to use a particular column in order to do that. So I'm using the date column to do that. So what does my inner join produce? So NYT DMD. And this just takes a minute to run. All right. And we can see here we've got dates and counts, right? So there's actually one thing I forgot to include here, sorry. You don't have to do it in any particular way, but this is probably one of the easier ways. All right. Lost a few rows there, which is what you would have expected. So now we've got, for every day that we have data for, we have the count and the M50, but the M50 still has the oh, my bad. Still has for every state. So the way you could have done this was, sorry, I'm making you watch me do this in real time. It's not really what I like to do. Summarize. Group by state. Summarize, which would be summarize the M50 by getting the sum of the M50. All right, so we do this and we're left with summarized by date. All right. Which would be added. All right, so didn't really mean to make you watch me do this in real time. I just wanted to show you the way that would be slightly easier before I show you the way that's slightly harder. But considering that we don't have a whole ton of time, I'm just going to show you the easier way, and then we can get to the harder way at another point. So basically, for every day, we now have the sum of the M50 within a state. Yeah, I'm going to copy into the chat. Yeah, sorry. All right, let me start by copying all this into the chat. All right, so yeah. My bad. And it's actually going to do this twice. So what does this produce? Basically, for every day, we have the total number, the total M50 for that day, and we summarized by state. So really, we actually didn't need this part. All right, sorry. I'm like doing this a little bit haphazard here, but you can now see here we've got the total for each day. So, all right, copy this all into the chat. There you go. So what have we done here? We've taken our New York Times data set, we filtered it only to have the confirmed cases, and now we have for each day, we have the count, right? So we now have data that is unique for each date. We now take our DMD, we group it by date, and we summarize the mobility within each date, and we select the date and that summed mobility. So now we have, again, unique for each date, the mobility. So we have unique for each date, the count, and unique for each date, the mobility. And all we got to do now is take these values and join them by date. And that gives us our final answer here, which is for every, oh, whoops, sorry. Got to actually run this. For every day, we have both the, oh, right. Yeah, I forgot to sum between states. Sorry about that. Gosh. Oh, all right. Group by states. Summarize. Count is sum count. Or you could just call this sum count if you want. All right, I'll put this in the chat again. My bad. Right, dates. All right, and that gives us for every date have the total number of cases. Just confirm that is correct. Yeah. All right, good. Yep, that looks correct to me. Just want to double check, make sure this is right before I say this is the final answer. All right, hold on a second. What have I done wrong here? Group by date, state, sum count. Select date. Don't group New York Times by state. Yep. This is way easier than I was making it. My bad. Thank you. That's a lot better. All right. My apologies, everyone. This is the correct answer now. This is the easy way to do it. No, that probably didn't seem easy, but as you can see, the code is now a lot simpler. All right, so how does this code work, right? So we've got now our New York Times. We filtered it, grouped it by date, and we get the total counts for each day. And then we take our mobility data, group it by date, get the total M50 for each day. This is literally identical, actually, the same process for each. You don't actually even need this select at the end. It will actually do that automatically. So this is even a simpler way to do it. Yep. So that actually does still work. So this would be the simpler way to do it, even simpler. And so that's the way this is working. You're taking each data set, you're grouping it by date, and you're getting the total of the value for that day. Then you do your inner join, right? Now, how can we summarize the relationship between these? Well, there's a few things you could do. You could do a correlation. Okay, so we'll do a correlation here where X is, New York Times DMD sum count, and Y is New York Times DMD sum 50. And we can see the correlation between these. It's 0.25. Is that actually significant? Well, you can actually test that with core.test. So you can see it is in fact significant. But let's say you wanted to actually plot this. Well, there's kind of an easy way to do that, which is to do, there's an easy way to do it. There's a hard way to do it. I'm going to show you the hard way first. Well, I'll just show you the hard way. Okay. So the hard way would be to do, well, sorry, no, this isn't actually that hard. You would just do ggplot. Yeah. ggplot, AES, X is New York Times, X is sum 50, Y is sum count, plus geom points. And now you can see the relationship. So there's probably some other confounders in here, but there you go. That's sort of in total how you would do it. Putting that in the chat. All right. So we're now officially over time. So I'm going to stop, take final questions, and tell you about next steps really briefly. So before we do that, any final questions here about what I've done to get this? All right, so any questions? Does this sort of make sense how we were able to quickly analyze our data to get a nice summary visualization? Okay. All right. Well, then let's talk about next steps. All right. So this workshop has been a distillation of some of the basics when it comes to using R for data science. And at the very end here, in a biological context, we looked at some epidemiology related data sets. Now, R is king for data science. And the reason is, I think you can probably see now, because largely of the power provided by the tidyverse and the other products from RStudio. So my recommendation to you all at this point is to continue forward, continue learning tidyverse, continue on, and especially when you're talking to people in rotations, tell them, I want to do bioinformatics as part of this. We have several other workshops. So our R and RNA-seq workshop is a really good next step after this. If you want to learn how to actually do now something that is a genomics, or I should say transcriptomics approach from the skills that you've now learned. But at the very least, I would recommend that you tell people you want to do bioinformatics, because that has a way of bringing out projects for you to work on that can get you publications. Now, I'll tell you, I did my rotations in a few different labs. My second rotation was in the Best Frost lab. And the actual project I did during that rotation was kind of small. It was honestly about on the level with what we just did today, if I'm being completely honest. But I got a middle authorship from just that rotation. This is the sort of thing that when you do bioinformatics can happen. And the reason is because bioinformatics gives you a rapid way to analyze biologically meaningful data and come to conclusions. You can see we didn't have to collect any of this epidemiological data. We only had to know how to process it using tidyverse in order to draw conclusions. So that is where I would say you would want to make your next steps. Okay, so Francine asks, when is the RNA-seq seminar going to be? Well, it's already happened, but it's one of our seminars. So all the videos are online. Everything is online. If you go to our website, bigbioinformatics.org, you go to R and RNA-seq. It's right here. So basically, you would want to start on week 5. That's where we actually start doing some more biological data analysis. And then week 6, where we actually start jumping into RNA-seq analysis. Now, DataCamp also has a course on RNA-seq, which is pretty good. So I would take that if you're interested in the RNA-seq side. But I'll just tell you right now that the best way to solidify your skills is to attempt a challenge. So you can either get that through your rotations, or you can come to our research network, which I would recommend all of you join if you have any interest in working on some of the projects we have. So our research network is bionet.dev. And this is something that we started about a year ago. It's grown quite a bit since then. We have our own Slack channel and community where you can join us and talk about projects. Basically, the way that we work is we have projects, and these are various projects that we have open source collaborations on. And so these are all serious research projects, many of them coming from our lab, since I was the one who originally started this, but also other labs as well. And if you want to check any of these out, go ahead, look at them. They'll tell you about the trainings required to join. So for example, this one requires a slew of trainings, 2 of which you are kind of now actually prepared to do if you have an interest in this, 2 of which you're not really prepared to do, but which you should probably learn the skills for anyways. If you go to any of these and you check out the trainings, basically you can see the tic-tac-toe thing we talked about in the very first session was actually one of those trainings. The training for R for data science is that Gapminder training I put in the notebook from last time, or not in the notebook, sorry, in the script from last time. And the RNA-seq training is a truly challenging training, but it will get you to do a real world professional grade RNA-seq analysis. If you can accomplish this, then there is probably no end of PhD advisors who are going to compete for you to join their lab. A lot of people need people who can do something like this. But I'll tell you, that's how I would recommend you go forward at this point. And if you want any help with that, you're always welcome to reach out to any of us in Big, and you're always welcome to join our research network. I'll send you all an update email with that later on. Yeah. Okay. Well, I'll put the link to it just in the chat here then. So it's bionet.dev. That's bio-net.dev. That's our website, bio-net.dev. I'll link this all in the course website later on. I'll do that tonight. All right. So with that, we're like way over time. Does anybody have any really quick final questions? Any questions about what we talked about in the workshop? Any questions about rotations, anything like that? IBMS 5000. If it's quick, we're happy to answer it. All right. If not, then it's been a pleasure talking with you all, and hopefully we'll get to collaborate in some future projects. But even if we don't, it's been a pleasure meeting you, and I wish you all the best of luck with your rotations and with this very first semester. All right. Thank you all. I'll stick around and answer any questions in case anybody has any that they want to ask. Okay. All right, gonna stop recording now. Okay.